Okay, so these notes relate back to the slope notes that we took last class, and it'll be a pretty quick set of notes. So when we talk about parallel lines, visually we know that that means the lines are never crossing. So parallel lines, maybe they look, I didn't do the best job there. Something like that, right? So they're not crossing parallel lines. They're never going to intersect. Now, what we know about parallel lines is that they have the same slope. So if I'm given a line, y equals 4x plus 3, so there's just a line. My slope here is 4. So any line with a slope of 4 would be parallel to this line. So let me actually see, well, let me write down perpendicular and let me see if I can maybe change my screen share to show you this in Desmos. When we think of perpendicular lines are intersecting. So here's a line, and perpendicular lines on our graph are intersecting at a 90-degree angle. So there's an example of perpendicular lines. Now, we also know things about the slopes of our perpendicular lines. So we know that they are opposite reciprocals. Opposite reciprocal slopes. So reciprocals, remember, mean that if I have a numerator and denominator, the reciprocal is I'm flipping that numerator and denominator around. Opposite means opposite signs. So if the original slope is positive, then the perpendicular slope is negative and vice versa. And you can see that here. This line is a positive slope and this line is a negative slope. So if I again go to that same line, y equals 4x plus 3, this slope is 4. Any line with a slope of negative 1/4 would be perpendicular. So if I look at 4, okay, 4 is 4 over 1, perpendicular to that would be negative 1 over 4. Or to give you another example, if I had a slope of 2 over 3, the reciprocal of that would be negative 3 over 2. So let me stop sharing this screen for a minute and go back and share. My just regular screen here, sorry. And if I share my screen and I go to Desmos, just to kind of give you a better visual of what's happening here. I think my internet's running low, so I'm trying to get closer to my router if I can. So looking at our graphing calculator, and I'll choose a different equation. Let's see, this might take too long. Oh, there we go. So let's say I choose, I don't know, 2/3. We already talked about 2/3. Let's do 1/2 plus 1. Okay, so there's my line, y equals 1/2 x plus 1. Any line with a slope of 1/2, so any line that has the same slope is going to be parallel. So I can just type in a bunch here, y equals 1/2 x plus 7. Okay, there's a parallel line. I could change it to plus 3. There's a parallel line. I could take out the y-intercept altogether. Okay, any line that has a slope of 1/2 is going to be parallel, I don't know if we'll be able to see that one, to my original line. any line that has a slope that's the opposite reciprocal, so opposite reciprocal of 1/2, if I take 1/2 and I flip numerator and denominator, it's going to become 2/1. And if I do opposite signs, it's going to be -2/1, or just -2. There's a perpendicular line, and I could add 5, still perpendicular, subtract 3, still perpendicular. Okay, so what's important is just the slopes here in terms of parallel and perpendicular. So let's go back to our notes page. And if okay, so heading back to our notes page, I think my internet's slowing down, so I'm going to give it a minute to catch up. We have this table. So in this table, here it's saying, here's my original slope of 2. And then what would a slope of a line that's parallel to it be? And what would a slope of a line that's perpendicular to it be? So if my original slope is 2, well, my parallel slope is going to be the same as the original, so also 2. My perpendicular slope is going to be opposite reciprocal, which means if I have 2/1, 2 is 2/1, flip that, is 1/2, and opposite, so change the sign. If I know the parallel slope is -1/3, well then my original slope would also have to be -1/3. And a line perpendicular to this, opposite reciprocal, would be 3/1. If the perpendicular slope is 5, or 5/1, then the original slope, again, opposite reciprocal, would be 1/5, an opposite sign, so -1/5. And a line parallel to that would also have a slope of -1/5. If my slope is 0, then my parallel slope is 0, then my original slope is 0. Now this one's a tricky one. And what's my perpendicular slope? So my 0 slope, remember, is a horizontal line on my graph. And 0 slope means zeros in the numerator. If I flip that reciprocal, now zeros in the denominator, and I can't divide by 0, okay? Or if I think about what perpendicular looks like, okay, perpendicular to a horizontal line is going to be a vertical line. Okay, so what happens when my slope is 0 is that my perpendicular slope ends up being undefined because I can't put 0 in the denominator. Okay, whatever the number we are going to call that, we can say, oh, this was 0 over a number. 0 over anything is going to give me 0. If I flip that around, now it's undefined because I can't divide by 0. So if that 0 goes to the denominator, it's going to be undefined. This one's also a tricky one because here I have 1/1, and if I take the reciprocal of 1/1, it's still 1/1. Okay, so if my perpendicular slope is 1/1, my original slope, again, reciprocal of that is still 1/1, but remember it's opposite reciprocal, so it's -1/1, or just -1. And if my slope is -1, then my parallel slope is also going to be -1. And so in the worksheet today, you'll get lots of practice with this. It's good to be able to fill in a table like this or identify if a slope is parallel, perpendicular, or neither.